Here in this video, we are going to talk about a new chapter called thermodynamics. So what is thermo? Thermal energy. Thermo means thermal energy, or in the other sense, heat energy. That is thermal. What is dynamics? Dynamics is like change. So thermal energy or heat energy, which changes to other forms of energies, basing on law of conservation of energy, that energy is neither created nor destroyed. It just converts from one form to another form. That means this heat energy can be converted into work and vice versa, basing on the conditions, whatever they are involved, and its applications. So thermodynamics is a branch of physics which deals with heat energy, conversion of that heat energy into other forms of energies, and its applications, right? So to study this thermodynamics, we need to have some basics, some fundamental physical quantities. Like to study mechanics, we have velocity, acceleration, force. Similarly, to study thermodynamics, we have some basics. That basics, basing on which we study thermodynamics, are called as coordinates of thermodynamics. So there are some basic coordinates of thermodynamics. What are the basic coordinates? Are? Let me tell you. Temperature. We know temperature is a measure of heat energy. Body with a higher temperature, heat flows from a body of higher temperature to a body of lower temperature, right? Then we have pressure. Pressure is defined as the force acting on a body per unit surface area. Pressure also decides or impacts temperature basing on the kind of the process that you are talking about. We have another term called something like volume. We know volume of a material, solid, liquid or gas, is definitely related to temperature. Now, in fact, temperature, pressure, volume each are related to the other things. In fact, we have derived an equation called ideal gas equation that relates all these things as PV equal to nRT, and we do use it here also. There is another physical quantity called internal energy. Well, the name itself says you that is the energy that is there inside the system, inside that thermodynamic system. System is a combination of what all are there who behaves together like a unit, can be called like a system. So its internal energy is the energy that is there inside the system. And how it comes? It comes due to many reasons, due to position of particles of the system or molecules of system. Due to the position of particles of the system, they do possess an energy called something like potential energy. So internal energy means potential energy is a part of it. But do understand one thing, that in the case of a ideal gas, for an ideal gas, one molecule is not related to the other. They are infinitely separated. Separation is infinite. That means potential energy is zero. There is no potential energy in that case. But anyway, internal energy is not only because of only position of the particles, but there are many other reasons. What are that other reasons? Are not only position, because of translational kinetic energy. As the molecules are in the state of motion, they possess certain energy because of translatory motion, like a regular kinematics motion. There is also a kind of another energy called vibrational kinetic energy. Molecules vibrates about their main position. That's because of oscillatory nature, and because of that also they possess some energy. And molecules also rotates about the given axis. That then it gets an energy called rotational kinetic energy. So in a normal sense, even if the gas is an ideal gas, though it has no potential energy, It still has translatory kinetic energy, vibrational kinetic energy, rotational kinetic energy. How much is that translatory, vibratory, and rotational depends on many other factors that we will discuss in the course of time. But all these energies together gives an energy called internal energy. And I want you to be careful that we cannot measure, we cannot measure absolute internal energy. How much is that? Is there internal? We cannot measure it because it is there inside, and we can only see its effect when it makes something, right? Otherwise, it will be just sitting inside. Ideally, we won't be able to measure it. Therefore, we cannot measure it absolutely, but we can measure change in it. So we see internal energy only in terms of change, as change in internal energy delta U as final internal energy minus initial internal energy. So this is one of the important parameter that we have not studied anything earlier, but in thermodynamics we will be talking about it, right? Internal energy. Finally, there is one more coordinate of thermodynamics called something like entropy. So entropy is a new term for you, and probably I just want to tell you as it's a measure of disordered energy. There is energy, but that's not in a proper order, and that is directly useful for you. You can't use this because that is not in an order. So if entropy is more, it's having a more disorder, then as it is in disorder, it's not directly useful to you. And being in, is it is in disorder, we can't convert that part of disordered energy into work. So if somewhere entropy is less, then the energy is in more order. Therefore, you are able to convert well into work into a mechanical work. Therefore, it's a measure of disorder of system, right? More the disorder, more the difficult it is to convert that into our regular mechanical energy. We can technically define it as energy per temperature, but we will restrain from that for a while and we will discuss as and when it is necessary. But now I want to tell you that to study thermodynamics, we have basics like temperature, pressure, volume, internal energy, and entropy. These are the parameters called coordinates of thermodynamics, and we will be talking about these parameters over the time again and again to study thermodynamics. So, thermodynamics is a branch of physics which talks about heat energy and its transmission to other forms of energies and its applications. That's it. Thank you for watching.